In this lecture, we are going to learn about different definitions, SN1 reaction and SN2 reaction. What are nucleophilic substitution reaction? When an atom or group of atoms is replaced by a nucleophilic compound in a substitution reaction, so the reaction is substitution reaction. Chemical reaction is called as nucleophilic substitution reaction or SN. For example, if we take an example, we have a substance Rx or any alkyl halide and we add a nucleophile to it. So what will happen after reaction in substitution reaction is this nucleophile will get attached to alkyl group and we will get R Y dash plus X. See how there is substitution taken place. Y says take my place and X says okay, I will take your place. So that is why it is called as substitution reaction. Ordinary light. It says that light made up of different wavelengths vibrating in all possible planes which are perpendicular to the direction of propagation of light is called ordinary light. You didn't got it, right? See, it is simple that when we are talking about a light bulb and it exerts light in all directions, so that means it will release small packets of lights in various directions, in perpendicular direction. So that is what is ordinary light, which comes from ordinary substances. Monochromatic light. Monochromatic ray of light consists of single color or single wavelength vibrating in different planes which are perpendicular to the direction of propagation of light. Monochromatic, by the name we know that it is mono means one. So the light which is getting exerted by any source in this scenario is of only one wavelength. There is no mixture of any other wavelength in it, so it would be exerting only one wavelength of light, hence it is known as monochromatic light. Plain polarized light. It is the light which is getting ejected out of nickel prism, where the light emerging out are vibrating in only one plane only. Such a wave of light which have different wavelengths of light vibrating in only one phase is known as plain polarized light. Optical activity or chirality. Property of a substance to rotate the plane of polarized light in clockwise or anti-clockwise direction is called optical activity. The ability of optical activity. What happens here is when a light is treated in any solution or is let out from any solution, given solution, suppose glucose solution, etc. So what happens, it can rotate in clockwise direction, also it can rotate in anti-clockwise direction, and so this substance which leads to this rotation of the light is known as optical activity of that substance. We already saw about optical activity, but what are the substances which enhance or leads to this optical activity to be performed? These are optically active substances. These are nothing but the substances which leads the plane of the polarized light to rotate in anti-clockwise or clockwise direction. Example is lactic acid, glucose solution in water, dextro-rotatory substance. By the definition we can know that it is the substance which has the ability to rotate the plane of polarized light in what direction? In clockwise direction only. So it is known as dextro-rotatory substance. Example is D-glucose. D means dextro or right. The plane of polarized light in anti-clockwise direction now is known as levo-rotatory. Levo means left. Example is levoglucose, a symmetric carbon atom. It is the carbon atom which is surrounded by 4 different monovalent atoms at 4 sides. So it will not have common or similar groups or substances attached to it on the 4 sides. It would be tetravalent. As you can see here, I am writing down. At all 4 sides, it is surrounded by 4 different substances. An atom. Molecules. They are the molecules which won't support optical activity, correct? So that is only the meaning that these are the molecules which cannot rotate the plane of polarized light or cannot support optical activity. When we treat a light here with any solution given here, the plane of polarized light doesn't get changed. Enantiomers. These are the isomers. What are isomers? They emerge from same parent only. Suppose we have glucose and we have 2 types from it. One can be L type or levo-rotatory, or one can be dextro-rotatory glucose. So they both have similar physical and chemical properties, but their optical activities are very different. They are non-superimposable. When we keep a mirror in front of them, in front of the formula, they are non-superimposable, and hence they are known as enantiomers. Racemic mixture or racemic. They are a mixture. They are a solution where equal amounts of dextro-rotatory and levo-rotatory solutions are made, and the solution which is formed is known as racemic mixture. Simple as that. Something which is known as SN2 mechanism and SN1 mechanism. SN2 mechanism got its name because a reaction in which rate of nucleophilic substitution depends upon both the substrate and the nucleophile. This is nucleophile and this is substrate, which is CH3. So it is known as SN2 mechanism. We can write the statement as rate is directly proportional to substrate and the nucleophile. That is how we can write the statement. Now let us move on to the main reaction. See, this is the general reaction, all the 3 processes. First is the attacking process, the nucleophile attack the substrate. Second is the transition state, and third is formation of methyl alcohol. First step is, now these are the basic 3 steps involved in this mechanism. First is the approach of the nucleophile. See, this nucleophile is approaching this CH3Br or methyl bromide or our substrate. So it will slowly and steadily approach the substrate, and what will happen, as you can see here, we have just added the nucleophile, and here bromine is attached to bromine has some bond with methyl group. What will happen is this OH group or the nucleophile, which doesn't have any bond formed yet, will slowly and steadily form a weak bond with CH3, and this strong bond which bromine has with CH3 will slowly and gradually weaken up, so that there would be formation of our transition state or further processes. Next is transition state, in which the complex is activated. This is the only stage where you can see carbon is attached to 5 substituents. This state is also known as transition state of reaction. At this stage, 3 hydrogen atoms are lying perpendicular to the plane of where the carbon is. As I said you, that OH group start forming weak bond with carbon CH3 and bromine, which had strong bond. This bond starts weakening up. Now we will see now stereochemistry of SN2 reaction. Now see, there are two types attacks a nucleophile can do on this substrate. First is backside and another one is front side attack. We will see it later on. First, what happens is, what if the nucleophile is attacking the substrate from the backside? And in this case, as you can see, this is methyl group, methyl bromide CH3. I have named it as H1, H2, H3. I will show you why. Then Br is bromine is attached here. But what if the nucleophile attacks from backside of carbon atom? Suppose carbon atom is facing there. See, as you can see here, it is facing there, so it is attacking from the backside. Again, there will be formation of transition state. What will happen? 5 constituents again will be get attached to carbon atom. The OH group will start forming a weak bond, and Br, which had a strong bond, this bond starts getting weakening up. Also, as you can see here, at the last stage where there is formation of methyl alcohol, after some processes, what will happen? OH will form a very strong bond, Br will get removed, and also there will be these H atoms attached to C will be as it is, but only there is replacement of OH in place of Br. That is only the difference. Now what if it attacks from backside? What will happen? So I am just front side. Okay, what will happen is OH, instead of, see this configuration, imagine it, I have got this or hold this in my hands and I am turning this likewise. So this would be like that. So here, instead of getting attached here in front side attack, OH will get attached here, and also it will form weak bond here. And what will happen is H2 will slightly move upward, so H3 will also move little bit up. So in our answer, the arrangements have changed, rest all is the same. Here I have constructed an energy profile diagram. This is a diagram of reaction coordinate against potential energy. As you can see here, I have marked down 3 points A, B and C. See, when we start a reaction, there is some energy level we are starting from. So we are starting from initial state at A. What will happen? It will gradually increase and it will reach to transition at B. Then after transition state, where the maximum number of changes occur, it will get changed to C. So at A, initial stage, there is where methyl bromide was together and nucleophile just is getting linking up. In transition state, the bonds are getting weakening up, the strong bonds get weakened and the bonds which are not existing start forming here. And in final state, when we reach C, we know that we get that the nucleophile has attached to substrate and the bromine has removed out as a product. So this is the graph of energy profile diagram, and the energy between starting point or initial state to final state is known as delta H. Okay, and this energy between A and B, initial state and transition state, is known as delta E of activation of energy or energy of activation, where it needs activation to gets transferred. SN1 reaction. This reaction takes place with tertiary butyl chloride. This is a two-step process. There are two transition states, as you can see here. First, when tertiary butyl chloride, see tertiary butyl chloride, so this will have 4 carbon atom and a chlorine group attached to it. There is no problem. Then when the slow rate determining step is undergone, what will happen? The bond between chlorine and carbon will slowly get degraded. This is the state after which there will be formation of carbonium ion. This is the first step where there is formation of carbonium ion. So here our carbonium ion is formed where chlorine group is said get out and rest all CH3 groups are living happily together with carbon atom. Now we come to second step where there is formation of product. Here the same carbonium ion, tertiary butyl carbonium ion is taken and a fast step is undergone where in transition state OH group can attack this carbonium ion. But there are two possibilities. This OH group can attack the carbonium ion from back side also or front side also. Back side attack and front side attack. What will happen from back when it attacks? There will be formation of, there will be 50% inversion of configuration. But when it attacks from front, here from front, there will be 50% retention of configuration. This is the energy profile diagram of this SN1 reaction. See, point A is the point from which our actual reaction of the first step began. Okay, we slowly and steadily increase our speed when we are riding a cycle or a vehicle. We start the vehicle slowly and steadily and increase our speed. At the same way, here from point A, the diagram or the chart or the readings will get increased. Point B is a transition state 1 where the bond between CH3, the bond between the carbon atom and chlorine was slowly degrading. Then the point C is the point where tertiary butyl carbonium ion was formed. Point D was transition 2 where the bond between OH and carbon atom was slowly getting formed. Then the point E is the point where final state is attained where we get our final product.